Welcome back to Math with Mrs. Wilson. Today we are doing section 8.7, Solve Radical Equations. And by the end of this section, you will be able to evaluate a radical function, find the domain of a radical function, and graph radical functions, which makes me realize that the name of this section should actually be Solve Radical Functions. Maybe we don't even need solve. Radical functions. Sorry about that. If a function is defined by a radical expression, we call it a radical function. The square root function is f of x equals the square root of x. The cube root function is f of x equals the cube root of x. To evaluate a radical function, we find the value of f of x for a given value of x. For example, f of x equals the square root of 3x minus 2. We are asked to evaluate for f of 6 and f of 0. Let's plug in 6 to the x. So in those parentheses, we put 6. And then we evaluate it. So just bringing down f of 6 equals the square root. 3 times 6 is 18. 18 minus 2 is 16. So f of 6 is the square root of 16, which also equals 4. Then we're going to evaluate for f of 0. So we're plugging in 0 into x. 3 times 0 is 0, and the square root of negative 2 is not a real number. So next section we'll learn about complex numbers. That's when we use I, but for this case we're just going to put not real. All right, I'm going to pause the video here and allow you to do the try it in your groups at the whiteboards. Go ahead and check your answer. Notice you only have one answer, the other answer is not real. For cube root and fourth roots, allow the same process. So we're going to plug in f of 4 into the cube root of 3x minus 4, plugging in 4. So f of 4 equals the cube root of 12 minus 4, which is 8, and the cube root of 8 is 2, so f of 4 equals 2. Now let's do the same process for f of 1. So we plugged in 1 into x. 3 times 1 is 3, and 3 minus 4 is negative 1. So what is the cube root of negative 1? It's just negative 1. Oops, I almost wrote negative 1 in my function. So f of 1 equals negative 1. And that's how you evaluate a cube root. In your groups, you're going to evaluate the fourth root. Be careful. You cannot have a fourth root of a negative number. That's not real. All right, so go ahead and go to the whiteboards with your group. Go ahead and check your answers. The next concept is the domain of a radical function. When the index of the radical is even, the radicand must be greater than or equal to 0. Right? We don't take the square root or the fourth root or the sixth root of a negative number, so it has to be greater than or equal to 0. When the index of the radical is odd, the radicand can be any real number. When you're ready, turn your page. So this is saying the same thing, but in a properties box. The nth root of a, when n is an even number and a is greater than or equal to 0, then the nth root of a is a real number. But if a is less than 0, then the nth root of a is not a real number. So that's if the radicand is even. When n is an odd number, the nth root of a is a real number for all values of a. So saying this again, if a radical has an even index, we know the radicand must be greater than or equal to 0. We set the radicand to be greater than or equal to 0, and then we solve to find the domain. For example, find the domain of the function f of x equals 4 minus 5x, and we're going to write the domain in interval notation. The first thing we're going to do is set this expression to greater than or equal to 0, and we're going to solve it. So subtract 4 from both sides. We get negative 5x is greater than or equal to negative 4. When we divide by this negative 5, the inequality symbol has to flip. Hopefully you remember that. If not, it's going to flip to greater than, it's going to be less than or equal to. X is less than or equal to 4/5. And then we're going to write that in interval notation. So the way I'm going to think about this is that x cannot be more than 4/5. So I'm going to put 4/5 on the greater side, and it can be less than that all the way to negative infinity, but it actually cannot equal negative infinity, so I'm just going to put a parentheses. Since it can equal 4/5, I can put a bracket. So x such that negative infinity up to 4/5, up to and equal to 4/5. That's interval notation, which I will reiterate, and as you're doing your try it, I will help you with writing it in interval notation. Otherwise, just follow the same steps and do the try it in your groups. Go ahead and check your answer, and then we'll do this next example. Find the domain of the function f of x equals the square root of 4 over x plus 3. Write the domain in interval notation. So for this, we need to think about it as what would make this become a negative. Well, the 4 in the numerator is positive, so to make it negative, we would have to divide by a negative number. So x plus 3 in the denominator has to be positive, so it needs to be greater than or equal to 0. When we solve this, we get x is greater than or equal to negative 3, but it cannot actually equal 0 because we can't divide by 0. So we are going to write this in interval notation as x, it's greater than negative 3, so that means it can go up to infinity, and we have negative 3, but it cannot actually equal negative 3, or it will be 0 in the denominator. So we write that like this, because x cannot equal negative 3. So it doesn't include negative 3, but it goes from negative 3 to positive infinity. So the parentheses mean does not include, and the brackets mean that it does include. Next example. Find the domain of the function if it's a cube root. Write the domain in interval notation. Well, since it's cube root, it can be any real number. So the domain is any real number. And so we would write that as negative infinity to positive infinity. We can't actually include infinity, and that's why we use parentheses. So x such that. Graphing radical functions is pretty fun. I enjoy graphing, so we get a visual of this. So the parent function of a radical function is this. F of x equals the square root of x. That's the most basic one we have. The index is even, and so the radicand must be greater than or equal to 0. This tells us the domain is x is greater than or equal to 0, and we write this in interval notation as it includes 0 up to infinity. Once we see the graph, we can find the range of the function. As we're looking at this, the y values of the function are greater than or equal to 0, so the range is also with a bracket 0, comma, infinity with parentheses. And notice how it has this shape of kind of like a sideways half parabola. So you can have a function, a table, and a graph, and we are going to practice that. So turn your page when you're ready. For this function, the square root of x minus 3, we're first going to find the domain. Part A, find the domain. X minus 3 has to be greater than or equal to 0, so x is greater than or equal to 3, and we can include 3 in this case. So in interval notation, that would be 3 up to infinity. So our x's can be 3 or greater. Before we graph it, we're going to make a table. So plug in 3. So we will evaluate this. 3 minus 3 is 0. The square root of 0 is 0. So when we plug in 3, we get 0. Okay. I want something where I take the square root, I get a number that is a perfect square. Okay? So if I plug in 4, 4 minus 3 is 1, and I can take the square root of 1. So the square root, I should put this in parentheses, 4 minus 3. 4 minus 3 is 1. The square root of 1 is 1. So if I plug in 4, I get 1. If I plug in 5, I get 2. 5 minus 3 is 2. That's not a good square root. 6 minus 3 is 3. That's not a good square root. 7 works because f of 7 gives us the square root of 7 minus 3. 7 minus 3 is 4. The square root of 4 is 2. So when I plug in 7, I get 2. 8 doesn't work. 9 doesn't work. 10. Nope. 11. No. 12. No. 13. Oh wait, 12 works because if I do 12, I get 9, right? 12 minus 3 is 9. I can take the square root of 9. So f of 12 equals the square root of 12 minus 3, and that would give us 12 minus 3 is 9. The square root of 9 is 3. So when I plug in 12, I get 3. From our table, we're going to graph this. All right, so I have x is equal to 3, y is equal to 0. When x is 4, y is 1. When x is 7, y is 2. And when x is 12, y is 3. And you can see this makes a sideways half parabola. And that is what the function looks like. So now we just did b, we graphed the function using a table. Now we're going to use the graph to determine the range. The range is what are the y values. So y values is, we're looking at this, right? The domain was this, it had to be greater than or equal to 3. But for the range, we're looking at the y values, it can be 0, and it can go on to infinity. It'll take a really long time to get to infinity, but it'll eventually get to approach infinity. It'll never touch infinity, so put a parentheses and then a bracket. So that is the range. I would like you to try the next one in your groups. Since it is graphing, the graphing part you can do on your paper. The table I want you to do at the whiteboards along with the domain as well. And then we'll come back and check. Take a moment to check your group's work. And then as a group, I want you to think of 2 things that you learned that are important today. Write those 2 things down in the summary and then set up your homework paper.